Morning, everyone. Morning, everyone.
Good morning.
You are going to need probably a calculator today. You might want your whiteboard if you have that handy, or pencil, paper, whatever. Those of you who are just joining, you might want your whiteboard today or pencil, paper, and you will need a calculator of some sort. Today, I'm going to have everybody turn on their cameras while I teach, because a lot of us are being really unfocused. So go ahead and turn your cameras on, guys. It's good to see all your beautiful faces. Wait a couple more minutes here for everybody else to show up. Sage, Austin, Michael, Anthony, the other Michael, Itzel. You guys need to turn on your cameras, please.
I just got home, so I'm running to my computer right now.
Okay.
That's why I'm not on.
Where'd you just get home from?
I work out in the mornings,
I gotcha.
and so I didn't have first period today, so.
Gotcha. I've been trying to get up early in the morning. So I usually get up at 4:30 in the morning, just so I can get all my kids ready and everything. I've been trying to get up to work out like at 4. Haven't been doing it. I have had to do my workout at night. Just too early. I start to wake up and then I'm like, I just can't function. It's just not going to happen. So I end up like reading the news on my phone or something. Itzel, Michael, both of you, Anthony, you're working on it. Sage, Zoe, turn on your cameras, please. James, I need to see that you're there. All right, we're gonna go ahead and get started. We may have a couple people join us still, and that's okay. All right, so you finished up your transformation projects. I have not had a chance to look at those yet. If you're not done, get those done and get them turned in, okay? They're big points, remember? That's like a 50-point project there. So get that finished and get it turned in. Yesterday, you worked on triangle angle sum, which was a review. That part was a review, right? But then you also worked on the exterior angle theorem, right? So on the exterior angle theorem, you learned, I had you watch that short video. Oops. I had you watch the short video, right? Where you had, if you had the exterior angle, So there's my triangle. And excuse me, if I wanted to find this exterior angle and I knew that this was, let's go 80 and this one's 20, what's the measure? Oh, that's a bad example. Let me go like 60. What's the measure of X? So yesterday you learned that the sum of the remote interior angles is equal to the exterior angle, right? So you got 80 degrees there. That was part of, that's what you did yesterday, right? Okay, in the comment box, put a Y for yes if you're okay with that, N for no, like you need to talk about that more. Okay, there's more than 6 people here, 7 people. So yes, if you're okay with the exterior angle, and if you're not okay. All right, so if you have questions about that, I expect you to ask me, okay? And guys, if you're not gonna respond to me, remember I can mark you absent. So you need to be focusing here. All right, so what we're gonna talk about today, people are leaving us. What we're gonna be talking about today is the polygon angles. Okay, so a polygon, if you remember, a polygon is, hold on, my computer is having a moment. All right, there we go. Okay, so a polygon is a many-sided shape, right? Poly means many. So we're just talking about a many-sided shape. So yesterday you specifically focused on triangles. Today we're gonna talk about any polygon. So as a quick reminder, and I did post these notes to Google Classroom, as a quick reminder, these are all your polygon names. Okay, so read through that list real quick. So 3 is for triangle, we usually know. 4 is quadrilateral. 5 is pentagon. 6 heptagon. I'm sorry, 6 hexagon. 7 heptagon. 8 is octagon. 9 nonagon. That's kind of an odd one. 7 is usually an odd one. 10 is decagon. 11 is called undecagon, and 12 is called dodecagon. Okay, now anything after that is referred to as an n-gon. So if it has, let's say 32 sides, it's going to be called a 32-gon. Okay, if it had 24 sides, it'd be called a 24-gon. All right, so anything 13 and over, you can just put the word gon with it. Okay, but it's not acceptable to say like an 8-gon. You have to know that that's an octagon. This should be review for you. We've talked about this before. Any questions there? Give me a head shake or a nod. All right, so next thing we're going to talk about is something called the the interior angle sum. The interior angle sum. I'm teaching triangle angle sum in my other class, and my brain is just not working yet today. So the interior angle sum. So we're going to talk about all the inside angles of polygons. The inside angles of polygons. So the sum of the measures of the interior angles of an n-gon is found by this formula. All right, so n stands for the number of sides. So what it means basically is if we have a pentagon, meaning 5 sides, I can plug in 5 for n and determine the measure of all the angles when you add them together. So we know triangle is 180, right? So let's think about that because we can kind of verify it. So we know a triangle has 3 sides. So what if I did 180 times, we have 3 for number of sides minus 2. That minus 2 is from our formula. We know 3 minus 2 is 1. So 180 times 1 would give us 180. Okay, so which we already knew, but I just want to kind of show you how that formula works. So let's give this a practice. Let's give this a try. It says, what's the sum of the interior angle measures of a heptagon? So first of all, how many sides does a heptagon have? Type it in the chat box. How many sides does a heptagon have? Good, Rachel. Good, Michael. It's 7. It's 7 sides, right? Okay, so I'm going to write our formula up here just so we don't forget it. 180 times the quantity of n minus 2. So let's focus on that heptagon. Okay, so if we know it has 7 sides, I need to take 180 times 7 minus 2. So I have 180 times what's 7 minus 2? We know that's 5, so we just need to take 180 times 5. So this is where I'm telling you your calculator is going to come in handy today. Okay, so if I have 180 times 5, it gives me 900 degrees. So what we're saying, what this does for us is if we have a 7-sided figure, okay, and I were to add up all of the angles. So if I add up the measure of all of these angles, all 7 of them, it's going to total 900 degrees. All right, is that okay? All right, next problem then. Let's look at octagon. Let's look at an octagon. So octagon we know has 8 sides. So we have 180 times 8 minus 2 this time. So we need 180 times 6. Okay, so if you type that in, you should get 1,080 degrees. All right, last one like this, dodecagon. A dodecagon has 12 sides. Okay, so dodecagon has 12 sides. So I want you to go ahead and calculate the sum of all the angles and type it in the chat box for me. All right, so those of you who are responding, it looks good. We got 1,800. Okay, so dodecagon has 12 sides, so I would need to do 180 times 12 minus 2. Again, remember that 2 is from my formula. So I have 180 times 10, which gives me 1,800. All right, so one more thing with this here. So it says the sum of the interior angle measures of polygon with n sides and unknown sides is 2,340. I want to find the number of sides. Okay, I want to find the number of sides. So we know if we use that formula, 180 times the quantity of n minus 2, if I knew the number of sides, they're saying the total here was 2,340. All right, so we actually need to solve this equation for n. The first thing I would do is just, we need to distribute. So I have 180n minus 180 times the negative 2 is negative or minus 360. Okay, so now I need to add 360 to both sides. So I have 180n is equal to, that'd be 2,700. And now I can divide that by 180, and we should get 15 sides. Okay, now, we did this algebraically, right? But you could kind of guess and check, right? If we know that formula, 180 times the quantity of n minus 2, I can start guessing, right? If I get too high, I know I need to back down the n. If I get too low, I need to increase the number of sides. All right, we could also go back and double check if you weren't sure. You could plug in 15 into this and double check that you get 2340. All right. Now, this might be some new terminology to you when it comes to polygons. You can have, remember how we had equilateral triangles, and that's where you had 3 congruent angles and 3 congruent sides? Okay, well, we can have polygons that can be what are called equilateral. Lateral means, the word lateral means side. So that root word means side. Okay, so it means all the sides are equal. So on the left there, you see a pentagon where all 5 sides are congruent. Okay, then we can also have something called an equiangular polygon. So just like the word sounds, angular, means all the angles are equal. So really what happened is they took that hexagon there and they just kind of grabbed the ends and kind of stretched it. So you can see that these 2 sides here are completely stretched, right? So that can only happen when you have an even number of sides, just so you know. Then when you put both of those ideas together, the equilateral and the equiangular, you get what's called a regular polygon. Okay, you get what's called a regular polygon. That means all the sides are congruent and all the angles are congruent. They're usually the really pretty ones. So like when you were in elementary school and they started having you do like shape recognition, you had to identify like a pentagon and a hexagon and an octagon. They gave you the really nice looking ones, the really pretty ones that were really obvious. Okay, so those are typically regular polygons. So knowing that all the angles are equal in a regular polygon, let's find the measure of one interior angle of a regular nonagon. So I want to know just one angle. So first I can find the whole sum. So let's find the sum. Okay, so we know that we have 180 times n minus 2, right? A nonagon, that's 9 sides. So I can do 180 times 9 minus 2, which I know is 7. So 180 times 7 gives me 1,260. Okay, so that's the grand total if I add them all up. Now, if this is a regular nonagon, that means all of the angles are divided equally, right? So that means I just have to take that sum and divide it by 9 to find the measure of just one angle. Okay, so that would give you 140 degrees. So we can do this how we divide it by the number of sides. We can do that when we have a regular octagon or a regular polygon. Okay, we can't do it just for any old polygon. We can't just divide by the number of sides for any old polygon because we had to have the extra stipulation that it's a regular polygon. All right. So we want to find the measure of angle Y in this pentagon. Okay, so pentagon we know has 5 sides. So I'm going to have you do this. Okay, so I want you're going to need to figure out this missing angle here. So start by finding the sum of all of the angles and then take away what you know. I'm going to give you a minute. Don't put it in the chat box yet, but go ahead and do it. And hold on to your answer for a minute. Would anyone like more time to think? All right, so we know we have a pentagon. So that means that I can find the sum of all of the angles by taking 180 times 5 minus 2. So 180 times 3 is going to give me 540 degrees, right? So meaning if I add all of these angles together, I should have 540 degrees. Well, I know 4 of the 5, so if I take my 540 and I subtract my 110, my 120, my 150, and my 90, if I subtract all of those in my calculator there, you should end up with 70 degrees. So the measure of this angle is 70 degrees. Questions on that one? All right, I know this is a lot of notes, guys. We're almost done, hang tight. All right, so that's all the interior angles of polygons. So now let's talk about the exterior angles. Okay, so remember yesterday you talked about the triangle exterior angles. Well, it doesn't matter what shape I have. If I extend sides like this, okay, we can create an exterior angle at each vertex. Okay, the sum of the exterior angles is always, is always 360 degrees. I don't care how many sides it has. You don't have to know a formula, nothing. It's always 360 degrees. All right, so knowing that, let's find the measure of angle 1 in this regular octagon, meaning all the sides are congruent, all the angles are congruent. Okay, so if I know the sum of all of them equals 360 degrees, all I need to do now is divide it by the number of sides that I have. So I have 360 divided by 8, and I get 45 degrees. Okay, something I want to point out to you here is, notice that an interior angle and an exterior angle together, they form a line, right? And we know a line is 180 degrees. So this is my exterior angle. I can now find my interior angle just by taking 180 minus 45 because we have that linear pair. So I can get my interior angle is 135 degrees without having to calculate, without having to go back and use that formula and then divide by 8. Sometimes if you know the exterior angle, it's way easier to find the interior if you think about it this way. Because that math it's just fewer steps, I feel like. All right, one last problem. One last problem. It says, what's the measure of an exterior angle of a regular nonagon? Okay, so regular nonagon, that means we have 9 sides, right? So I need to take 360 and divide that by 9 sides. So you should have 40 degrees. So every exterior angle of a nonagon, so if I have my nonagon here and I extended one side, oops, sorry, trying to extend a side there. If I were to extend that side, we're saying that this exterior angle right here would measure 40 degrees, which means that I can find that interior angle. Remember, that's 180 because I have a linear pair. So 180 minus 40 gives me 140 degrees, which we discovered earlier, right? We did that back here. We said we had, well, maybe we didn't finish it. We just did the 900. But I could still take that 900 and divide it by 9. Maybe we did. Okay. And now last one. Regular pentagon. A regular pentagon. So I want you to do this one. Okay, I want you to find the measure of one regular pentagon. Some of you guys keep turning off your cameras. I need you to turn it back on, please. So you find the pentagon and type it in the chat box, please. Nick, you need to put an exclamation point behind that. Say it with authority. It's 72. There you go, Anthony. There you go. All right, so if it's a pentagon, we know that's 5 sides, right? So I just need to take my 360 and divide it by 5. All right, and that's how I got my 72 degrees. All right, so out of this, 2 things you really need to know, and you can figure everything else out. The sum of the interior angles is that 180 times n minus 2, right? That formula there. And the sum of the exteriors is always 360. All right, for your homework, I want to show you what it's going to look like here, so don't leave. All right, so for your homework, this is what it looks like. Okay, so this is a pixel art, but notice I say here, you need to view it at 50%. Okay, so I made the text large enough that on your Chromebooks, if you view it at 50%, you're gonna be able to see the whole picture and you can read the questions well enough. Okay, I'll try to, my desktop is a little skewed, so I know it looks super blurry here, but the idea is that all of these problems are to the right, okay? And if you're correct, your answer is gonna show up, or I'm sorry, part of the picture is gonna be revealed on the left, okay? Again, if you put it at 50% up here, if you make that view 50%, you'll be able to see everything. And I made the font and everything large enough that I think you can read it. Like I can read it and my eyes are bad, I'm old, okay? So it's gonna start with 2 easy questions up here, just talking about your formulas. Those are drop down. Okay, then the rest you're just going to type in, finding the sum of the interior, finding the sum of the exterior, and then thinking about just regular polygons. Okay, then over here I have some problems where you have, I'll zoom in so you can see it a little bit better. On the far right in the orange, you have problems where, oh gosh, where I give you a polygon. You have to count the number of sides to determine how many degrees all the angles add up to be, and you have to solve for x. So you have some interior here and some exterior. All right, so I don't want you to leave. I want you to get started on this. Okay, so everybody pull this up. If for some reason these pictures don't come in on the right, just hit refresh and they'll come, okay? There's a lot on this page, so it might take a second. But I want you to go ahead and pull that up and go ahead and get started. Leave your cameras on, please.
Is it assignment 62?
Say that again.
Is it assignment 62?
Yes.
Okay.
Sage, James, are you there? Austin, are you there?
Yep.
Okay, you just weren't responding in the chat, so I just want to make sure you're there. Guys, some of you haven't even started yet. So get the assignment pulled up and get started, please.
My internet is being so slow.
All right. All right, so if you need to get off, go ahead and get off, but you need to work on this, guys, okay?
Okay.
All right, have a good weekend.
Have a good weekend.
Bye.
Have a good weekend.
Thank you, you too.
Is the box supposed to turn green when you get it correct?
The box won't turn green, but part of the picture on the left-hand side will appear.
Because one of my things is green. I don't know why.
I could have goofed something up. But I think it should work in the end. Like, I think the picture should still be. It should
Yeah,
still
it's showing up on the bid thing, but
Okay,
it just turned green. So I don't know why.
okay. Sorry about that. Okay, guys, I have to go to my next class. I hope you have a wonderful weekend.
You too.
Bye.
See ya.
Adios.
Bye.